I know she's doing it, yeah. So she's doing it again this year. Yeah.
Okay, well, we'll get started with this basic overview of the system. Okay, well, I can use this one here as an example. You can probably see the same thing on Dave's. Dave's system is spread out a little bit more. But we'll start with very, very basics. There's 110 volt power. So 110 volt power is coming into a hand switch. It's going into a second hand switch. So it takes both hands to operate. That's 110 volts. So there's no difference in pulling the trigger on a drill or any normal 110 volt appliance. From this switch, the power goes into the transformer. The transformer changes it to usually 9,000 or 15,000 volts. These are dry core transformers. Like Dave's is a dry core transformer. And the difference between a dry core transformer and Ken's, which Ken's, so maybe just grab it here so people can see it and make sure that they know the difference. The dry core transformer is just a coil of wire. And the electronic ones have a very small transformer in, but they use capacitors. So something like this is considerably lighter, right? And it's a neon sign transformer. It does all the same thing on a neon sign. The only thing is it stores energy in the capacitor on the high tension side. So even though you shut the power off to you still got power, potential power. So I would recommend if you're looking at getting parts for a system, stay away from the electronic ones. Stay with the dry core, because when you turn the power off to the dry core, it's dead.
Oh, what about the ones that come out of microwaves?
Microwave transformers are not current limiting. Lots of people will use a microwave transformer just because it's a transformer. It gets you up to around 4,000 volts. But when you dead short a microwave transformer, it's a dead short. It will blow a breaker, blow a fuse, because the transformer is not designed to be current limiting. It's designed for a microwave, and that's what it's good for. These transformers are designed for neon signs. They are designed with current limiting. So if you short them out, like when you put the burning cessation goes on and the carbon track goes and it's a dead short, the limit on the transformer is self-limiting. So you can only get a certain amount of energy. And that's the main difference, is the neon sign transformer is current limiting, so it doesn't matter if it's a dead short. Right? But a microwave transformer is a dead short. You have no control. That's usually why they flash and burn and smoke, because it's an incredible amount of current. Another thing, the current is what does the burning. The microwave transformer has no limit on the current, so it will just blast. It's uncontrollable. On a neon sign transformer, it's current limiting. So now you have control. The most current you're going to get is what it's designed for. So it takes a little longer to burn something, but it generally gives you a nicer burn, a nicer filigree. So
what kind of amps are you looking at with these?
Typically 35 milliamps. Okay. So 35 or 65 milliamps, depending on the sign that they come out of. So talking about transformers, all the transformers I've got here came from a neon sign transformer company. A lot of sign companies are changing from neon to LED. So these are all used, and they're surplus. They're basically going into a recycle bin, because they're copper, right? So they're garbage as far as they're concerned. There's a neon sign company in Edmonton that has probably 50 of these in stock all the time. Like, they're changing them regularly. There's a neon sign company in Calgary that has them. I got mine from the guy by the name of McDonald, I think. Dave, I can't remember the guy's name.
There's another side. There is no fit, just on 26.
Okay.
And 32nd.
Yeah. So an interesting thing is another transformer is similar to the one that Dave's got and similar to the one that I have. I set it up yesterday. I was going to bring it, and the transformer is no good. So before you ever hook anything onto the transformer, you check with the multimeter, make sure that there's continuity on the low voltage side and that there's continuity on the high voltage side. That means the transformer is good.
So it was a good deal.
Yeah.
We had it all hooked up and ready to try. Hey, this ain't working. What's going on?
The next really important thing on the end of this is the wires that are coming out of the high voltage transformer. Usually 15,000 volts. And it's really important that you use 15,000 volt insulation wire. It doesn't have to be thick wire, it can be really, really thin because it's only milliamps. But the insulation is required because this is like you're wrapping them together like this, and they're, you know, they're touching around, they're touching other stuff on the table. You want that to be rated for the voltage, so that you don't, if you short circuit it, it's not going to hurt the machine, right? But if it's touching anything else, you don't want that to be energized, right?
I don't think you need a long wire, like I feel this wire on this one we put together yesterday, I think the wire's too long.
So these are pretty long.
Yeah.
I think it depends what you're burning though, and how.
Well,
far away
that's
you're
right,
going.
it does, but you know, I think anything that I would work with, I'm sure the short wires will reach to where.
90%.
Yeah, yeah.
Well, and that's.
I like the way this is set up, though, like it's all, you know, hard.
Yeah, I'm
Yeah.
gonna do that too. I
Yeah.
got everything loose and it's
Yeah.
a bit here and a bit
I
there.
got
Right.
it, like,
Yeah.
I'm gonna put mine down on a piece of wood like that, so
Yeah.
I forgot to switch it.
Yeah.
Yeah, well,
Coming
like
here.
yesterday
Yeah.
I put this
Great.
together, I had all the parts and I was just gonna bring all the parts, and I thought bringing all the parts would be, to this group would be counterproductive because, I mean, you guys, you wanna see it assembled. So I did this yesterday, right? It's all on board.
Yep.
It's simple, it's still his idea about putting or putting legs under it so I can get my fingers underneath it.
Oh, his is prettier though.
It's got-
No, but it's,
One of the small features on putting a system like this together is making sure that the switches are hardwired to the transformer
Yeah.
and hardwired to a plug-in. And the main reason for that is, if anybody else that doesn't know anything about this plugs it in, you're never gonna get any power coming out of the transformer unless you push both switches, right? You don't need a variac to make this work. If you plug this in and use the two switches, you'll have the full output of the transformer. That'll burn pretty substantially, sometimes it's pretty good. The reason that I use a variac is it now gives me control of the amount of voltage that's going to the burn. I've found most of the burning will happen between 2,000 and 3,000 volts. The odd piece of wood, maybe oak, might like to have a little bit higher, but by having the control of the voltage, you can control when it starts. If it's too wet and you don't know if nothing's happening, you can turn the variac up and you can see that it starts to burn. That's an indication. But even easier than that, and what I do all the time, because I'm a control freak, I put one of these kilowatts. This is just a little meter that tells you what the power is. Dave's got one there, it's a different model, but it does the same thing. You plug it into your 110 volt supply, and it turns on and tells you that we've got 120 volts. Well, that doesn't tell me much when I'm running a system, because that's voltage, it's going to stay the same. So you switch it to watts.
Watts,
You can
yeah.
use amps. Amps in is equal to amps out with the calculation, but watts in is power and watts out, so it's roughly the same. You have a few losses with the transformer, but if you got 50 watts going in, chances are you got 50 watts coming out. What I use it for is that when I'm powering, if I've got nothing happening, I look at my watt meter.
Yeah.
If I got 30 watts going out and nothing's happening, something's happening.
Yeah.
It's just the power
So
meter
when
is telling
you
you.
two had that stall, if you got the watt meter, you can actually see
Yeah,
you got, it's working, it's just
Percolator,
not burning.
yeah.
yeah.
You know?
And so then with,
Not adding more water.
No, well,
well, if you add more water, it'll actually give the electrolyte so you won't get
Yeah,
any
you
burning.
gotta go the other way.
Yeah.
We actually learned that already.
They learned
That's good to know. So again, I put it on watts, and to start this system up, it's on 0, right? Because I've got it on watts, there's nothing happening. When I turn on my variac, it takes power to turn the variac on, but electrically, because there's coils in there. So as soon as it's like turning a light switch on, when you turn it on, light comes on, takes power. So this variac, just to turn it on, is 2.7 watts. That's just to turn the variac on, nothing coming out. Now I've got power to the variac, and I've got it at 0. There's a little meter on here that shows me 0, so there's nothing coming out of it. If I push the buttons, nothing happens. I push it on here, there's no current going, but the transformer is live, could be live. Bring this up to about 50% and push the buttons. There's still no power. Oh, it's got 7 watts going out. So there's actually something happening on that dry piece of wood. So we've got a dry piece of wood, and putting the buttons on it, there is 7 watts of power going across that dry wood. Right? It would take a long time for it to start to burn, but that's just natural wood. They say wood's not a conductor. Okay, well,
There you go.
there it is.
Just depends on what the wood is.
Yeah, so that's a good point, because a transformer is everybody familiar with what a transformer looks like inside? You got a wire coming in, 110, it's a bunch of coils and goes out, that's 110. On the other side, it comes out, a bunch of coils and goes out. Well, the transformer is isolated. So between these two high voltage wires, there's no connection between here and the 110 volt side. Right? So if we have current flowing here, there could be current flowing here just showing us the transformer is working. So in order to get something bad happen to you by standing on here, the power going out to one of these wires is not trying to come back to here. It's trying to come back to the transformer. So that's why when I set my systems up, I'm always on this side of my transformer, and I never touch that unless, if I take my hand off the switches, there's no power there. So it's important to note that you're not going to get electrocuted through the floor or through the table. When I'm doing some of this at home, some people get freaked out because I have it on my table saw. My table saw is this, right? It's metal, right? I got this in a box, but I'm not worried about it going through the metal of the table saw because it can't. The power is trying to come from this wire back to this wire, right? But it's always nice to have a nice wooden table or a plastic. I do it on a plastic table too if I don't have my table saw in.
How far can it jump?
This can jump, depending on the voltage. You probably can try that here. Have you ever seen one of those kids' toys with the yard? So this is very similar. I don't know if we can make this jump there or not. There it is. Yeah. Well, it's jumping because of the wood, right? Because it's sitting on the wood. I'm trying to set this up so we can. Let's see if we can make that jump across there. Yeah.
Just like a spark plug.
That's just exactly like a spark plug, absolutely, yeah. So that brings up the other question of what other transformers can you use? We're using neon sign transformers. You can use a furnace, an oil fire furnace, has a transformer on it to ignite the oil. Lots of people use those transformers. They're a little smaller, cost about the same. I think they're about $200, $250 to buy one, but they're the same thing. They're current limiting, because they know how much current it takes to make an arc, and so even if you plug them in and dead short them, they're not going to blow a circuit. They're just going to sit there and arc like that and make them, that's what they're designed for. And they do a good job of burning as well. We'll slip over to the chemistry now. Electrolyte. Electricity likes to flow through electrolyte solutions, usually a salt solution of some kind. What do you guys use for electrolyte? What have you used in the past, or what have you seen used?
I used what you gave me.
What was that, baking soda or chloride?
No, the good stuff.
Yeah, okay, magnesium chloride.
Yeah.
And
And there's very little, like, you don't need
I
much.
brought a jug.
I brought this here, I've been using this for 3 years.
Forever,
Oh,
yeah.
when-
Yeah, mine too.
When's the last time you were at my place there?
Yeah,
it doesn't-
exactly, it doesn't take much.
What strength do you use for water and salt?
I go
Till the
saturation.
crystals- Till the crystals don't dissolve.
Yeah,
Okay,
yeah, and, that's a really good question, because lots of people say, well, is it 1 tablespoon or 2 tablespoons? Well, I'm a control freak, so I'm trying to think, well, how can I control something? So I've got control of the variac, I've got my monitor so I know how much I'm doing. Now the solution, if you go with all these different 1 tablespoon, 2 tablespoons, it'll change the way the stuff works, and then the wood changes too. So I went to saturation. I keep putting this stuff in until it doesn't dissolve anymore, and now I know that every time I use that solution, that's the same. Now any difference, it's got to be the wood.
The wood and how much you put on.
And how much, what I don't like about baking soda, and we can
Stains.
probably show it on here, is it stains the wood.
Oh, you said that, yeah.
Yeah, and that's, I mean, it works. If you're only gonna put a little bit of baking soda on, you can see how it's changing the color of the wood there.
Yeah,
Is that baking soda you got?
That's baking soda, and this is magnesium chloride.
And actually, I think if you use the darker piece of wood with baking soda,
It comes up white.
it would be real bad.
Yeah.
Like I think there's a,
Bell around? I thought it was too much stuff on.
so the other thing is after you're done burning,
Yeah.
and you wash it off. Have you ever seen magnesium chloride stain it so your stains are different? You know, like if you're putting in walnut stain or,
I haven't seen
I
it.
haven't either.
I haven't seen it change the stain on the wood. What I have seen is the baking powder tends to make a wood turn a bit greenish.
Yeah.
And the magnesium chloride, I haven't noticed that, right? So I've done some things on maple, it's white, and only did a little piece of magnesium chloride, and when you wash it off, it's the same color. When I did it with baking soda, the place that I had the baking soda had the stain, you could see the edges, so that's why I didn't like it.
I was,
You do the whole thing, and then it's all the same color.
I was looking for that problem too. I don't have it because I use the good stuff.
Yeah.
But you can bleach it afterwards. But there is another
yeah.
chemical
Process.
process.
Yeah.
It's hydrogen
Yeah.
peroxide.
Yeah.
And
I have 50% hydrogen peroxide.
Yeah.
It'll make anything snow white.
Yeah.
Well,
Like some woods again, it gets green, right? They bleed. You've got to test that.
well, not maybe with regular bleach, but you got to have the right
No, I
combination.
have the
Like
right-
27% of the one.
Yeah, the one they also have at home harbor with the cookie control.
Well,
Yeah, no, that doesn't even work.
Calcium chloride, potassium
Yeah, that's
chloride,
Yeah,
Oh, okay.
and just table salt.
yeah,
They all
sodium
stain.
chloride, yeah.
They all stain.
Epsom salts does the
Yeah.
same, yeah. So all of those things are electrolytes.
So just based on playing, I think magnesium's probably the best so far, but
It's the cleanest I've found so far, so I mean, that's, not just because it stains or doesn't stain, that's the only reason I switched. I brought borax with me too, that's, if you're interested in something that gives you a little bit of different, a different burn pattern with borax. It's an electrolyte, but it doesn't stain the wood, but it gives you the real wild, burn pattern. So
There's another piece of wood there if you want it.
Probably we'll put some borax on there. But the borax was, I read up on it somewhere where somebody said they tried it, and I thought, well, I gotta try it just to see what it does.
use a brush.
And again, using borax, changing your chemicals, do you try to saturate your water?
I do
with
that,
those?
yeah,
Yeah, okay.
all the solutions I've used are whatever the chemical they are, I run it to saturation because I don't wanna be able to screw around with, recipes.
Yeah,
I mean,
yeah, okay.
it's too much to remember.
Constant every time.
Pardon?
Give you constant every time.
Yeah, at least that's constant.
Yeah.
I mean, there may be some point in the future where I might try it just because I want to, but this now is all consistent. Now the difference is the wood. These two woods are popular. So we've got baking soda, we've got mag chloride, and we've got borax. And we'll be able to see what the difference is in between the three different chemicals.
Yeah, I find if you just keep consistent, and then you got voltage you can play with,
Yeah.
you know, that's,
Voltage is really handy for building the detail, the filigree portion with real fine detail. I find this is really great. There's been times when I'd like to be able to adjust this while it's burning, but I have to keep my hand on. And you know, as silly as that sounds, your system only has one switch, right?
Yeah.
So when we built his system, he only wanted one switch. Well, it's his system. I was anal enough on mine and on Dave's to say, we need two switches because I want whoever's doing the burning, I want both of their hands in one place, right? So if I'm gonna help somebody, they're gonna have both hands in one place. There's no way they can touch the things with their
but Bert, I still find,
I still work.
working here with all these people, everybody wants to grab, like, you
Yes.
can't do that. I mean,
That brings up, that's a good segue to the next comment on the safety end, but whoever is on a set of switches is responsible for their work area. Normally, I'm by myself, my wife knows I'm out there, and if there are one or two people, one person, I taught my grandkids how to do this because they're always interested, so they know how to do this, they can set the system up and they know the safety aspects of it, and so now they know it and they're off doing other shit now, but they understand it, that the safety switches, and if anybody's in the room, they don't turn power on, right? That's just, you know, we train
The rule,
everybody
yeah.
how. So with all these people around and all these systems, we just have to be really conscious of whoever's on a set of switches, if you see anybody close, get your hands off, right? I mean, that's, I can't overstate that enough, that we're all responsible.
but
for
it's
our
a
own
natural thing, like, you two guys, when it's stalled and it's not
Yeah.
doing nothing, you kinda,
safety. Well, it's funny, you want to do it yourself.
No,
And it's clear,
Yeah.
And then he was,
You're making a story, but.
Yeah.
Well, no, but it's tempting, right?
we were quite aware of that, that there were two of us. And before anything happened, it's just like spinning a prop on a
Yeah,
plane.
absolutely.
There's a pilot in the plane,
Yes.
but somebody's gotta spin that prop.
Yeah.
And I was telling him, my hands are clear, now you're clear to go ahead.
Yeah, absolutely.
Still, you're right, but not quite.
But it's tempting though, right?
Well, I think
You're right.
I think the
But
main point
always,
is,
you're
we're
right.
human beings in the room, it's
You
so
were
easy
aware of
to
that.
overlook it. I mean, we can't overstate the safety portion of it. With this many people in the room, it's very, very easy for something to happen. So we're just reiterating that, just be conscious of it. And you're right, hands clear, lets everybody know that you gotta be clear, right?
But you're right, you can't overstate what your comment was there. You're 1,000% right for what you said, about the safety and what your
Absolutely.
awareness. You're
Yeah.
1,000% right.
Yeah, I mean, and that's the whole idea for doing this little exercise, is to make sure that everybody understands where the dangerous parts are. And we've got high voltage written on here, I wrote it on here, just as a reminder, right? When I'm doing it by myself, I'm always behind my box, right? That's why, another reason why it's in a box. Same with this system, it's in a box. Hands are over here. So just by the very nature of the system, I can't. I mean, I can't forget, but I still find, I put these things far enough apart, I can't use my hand on it.
That's the other thing.
Well, you
Switch
could-
for it.
But you know what I found myself doing?
Yeah, we talked about that, eh? Because I said
So
that,
that way
you know,
you
I
can
could do,
go
so therefore, one switch is good enough for me.
Well, now it's good enough for you, and that's right, it's your system. But I still
That's why
find
you-
myself wanting to do that.
That's why you got your bearing in the center. That's why you got your bearing in the center. You got a mountain to go over it.
Use those clamps, clamp posts.
So there's any number of ways to defeat a safety system. The idea here is that usually you have both hands here. So before you put any power on, here we've got, this is turned on, variac's turned on, it's at 0, we've got baking soda, and we put power on, there's nothing happening. We bring the power, I usually go up to 50% and hit it, and now it's burning. So I usually play with it, and I take it down to see, okay, what is it very, I'm down to 12% on the variac, and that's 4 watts of power, and you can see it's burning, okay?
So 4 it says,
4 watts.
and we use 2 for this one, right?
This is
So it's
how I
only
know.
2?
Yeah, this is.
So only 2 at the end?
Roughly 10%, yeah, you're exactly right. So this was 2 watts just to turn this on. When I punched this, it went up to 4, and it's
Just
burning.
2?
So it's only 2 watts of power is
Very
burning
little.
at 10%.
And here's a solution for your problem.
Put a handle on it. So that, I mean, by having this on here, I like that because I can say, okay, I put power on, that's 2 watts at 10%. So I do that with a lot of the woods to understand which wood burns which way. So I started this at 50, and look at it go, right?
But you
And we're
lose,
drawing 35 watts.
you lose a lot of detail, like if you
You
go
can.
slower, you get
So you-
real.
You go
You get
slower,
more
you can
feather.
get a little
Yeah,
more
yeah.
detail, a little more,
I like it when it's just barely burning.
yeah. And if you turn it right to maximum, so that's basically
Now watch
the
this.
full output of this. Oop, yep, you can hear the hum and see it go.
And how much, what is it now?
It's drawing 85 watts. Now, there's, now that the,
That's why I brought this for putting on the fire.
yeah. Now that it's dead shorted, and I'm still holding the power on, if you
Yeah.
drop down to 60, the only thing
Slow
that happens is it burns deeper.
Yeah?
And sometimes that's advantageous. You want it to burn deep. If you're gonna fill with epoxy or something like that,
Yeah.
you'll want it to burn deep.
Yeah?
The only thing you have to be careful though, like I burnt right through, it comes through the backside sometimes, it depends on the wood.
Yeah.
Like that one with the knot, you guys burn that and you'll see,
Yeah. you
just
can-
give her and see what happens.
Yeah.
And,
You remember the platter we did at your place, Joe? You had 2mm platter?
Yeah.
We burnt the platter without burning through.
Yeah.
Because we have a
you dial it
variac,
down.
right, we back way down, and so and we're just going just barely burning and getting really nice filigree on a 2mm thick piece.
I tried carving with it, like doing that.
In a sense, you wanna use as little power as possible,
Well, it depends what kind of pattern that
Depends
you
on
want
how
there.
you want.
but to get the most
I'll be
filigree.
right back. I've got some, I've been burning with a pen, Okay. With the,
Pyrography.
yeah,
Yeah.
but I also have a large bowl that I want you guys to see if you can.
Perfect, yeah, absolutely, yeah. So I made a lot of Christmas ornaments like that, just all over the mouth. And out of all the Christmas ornaments that I have, they're bulbs. If I have one of those, it disappears. If I have just Christmas ornaments all nicely shined up and everything looks pretty, people look at them and think they're nice. And I hang one of those beside it, it
Going
disappears.
right away, yeah.
So I always use the regular ones that are plain looking and hang one of these in it because people will gravitate to them. Yeah. Another thing that people gravitate to is coasters.
Yeah, that's nice. That's nice.
I mean, they're just a piece of wood
Yeah.
and they're,
So can you make any the same?
no. That's why I say it's
That's a
easy-
test, man.
Yeah, no kidding. Well, if you can, I'm impressed.
It's
In
easy
a
to
sense,
use
the
wood.
plainer the wood,
Yeah.
the more important what doing adds to plain wood.
But it looks way better with the finer detail, like you look at it.
Yeah, oh yeah, it's prettier.
I love the filigree of it.
Yeah,
I don't want to have.
yeah, exactly.
Here's my very first attempt at burning period. These here. And, but this one here, I burnt that last night.
Oh, wow.
Now, what I wanna do,
Yeah,
I'm asking you, is there any way I can make that go around here? Right on this edge and flare out in between the leaves?
yes and no. You can make it go around the edge,
Yeah.
but you have no idea exactly where
Where
it's
it's
gonna go on
gonna-
the other end, exactly. But it can go,
Because you see, it's obvious, this is two pieces.
yep, yep.
But what I would like to
Trouble
do.
with your grain is
I
different.
wanna hide that crack, and if necessary, I'll put leaves down on this side as well.
Yeah.
With,
You wanna hide the crack.
I started to burn some berries, there's a little spot there.
Okay.
Right here.
Yeah.
Started to burn.
Trouble is you probably-
me.
It's hard though, you burn into the leaves.
But anyway.
too.
That was my question.
The way that you control a little bit of that is where you put the solution. So if you take a paintbrush and paint your solution on where you want it to go,
Yeah.
and then the placement of the probes. And again, with the Variac, you have a chance of being really successful because you can go at like 4 watts. Here, we're on the magnet chloride now, and at 0 should be nothing. We'll go up to 12 again, nothing. We're at 10 watts there. Now,
It just started there.
it just started, so now, if you're doing what you're wanting to do there,
Yeah.
okay, we're at 36% and we're at 11 watts, and you see where the burn is,
Yeah.
right? And now, one of the things that I heard you guys talk about earlier, if you only wanted to burn in one location,
Yeah.
make one of them really wet. It still conducts electricity,
Mm.
but now it'll only
Yeah.
burn from one end.
Yeah.
Right, so it's only burning from one end.
So that's how you can control your line.
So,
You
yeah,
got it wet on both
and
sides.
another thing, and I'm glad you brought that because it's a segue into, I didn't know if I was gonna get to it, but another thing that I use when I want to really control it
Yeah,
is, I don't know if you've seen me do that.
I've done it.
Yeah, where you'll set this up and you put a whole bunch of solution in here. Just put a whole bunch in here. Right.
That's your ground.
And so that's one thing, and then if you've got a clamp, is this something we can burn?
Absolutely. That's,
So we got
yes.
just a spring clamp?
Yeah, right here.
Want to hang it in here?
Oh, you even got one of those too, that's right too, Dave, you got that.
Oh, we can use that, we can use that hole right there as well.
Oh, what I've done too is
This
go
is
like this.
expensive.
Okay, so now the edge of the bowl is in the liquid,
Yeah.
right? There's no way in hell that that part's gonna burn, right? So now you can take this and you can put stuff wherever you want on here, as long as there's a line going down to the bottom. Right, it'll make the connection. Let's just try this. Here.
You said it in
In the solution. As long as one of them's in the solution down here. And then we'll see what happens. Okay, so again, always start at 0, making sure you know what the power is, try it. Okay, there's nothing going out there, so we may not be making connection, but we'll crank it up to 50%. We'll try it again. Now we got 10 watts.
Oh,
Now,
yeah,
see, it's not burning on the bottom, but it's burning on the top.
Yeah.
Okay, so that's 30 watts of power going in there, so it's burning a little bit. It's a thicker bowl and whatever. So say that's the filigree that you want in between your leaves.
Yeah, yeah.
Okay, so then you turn and you can move this over. Okay, this is still in the liquid.
And you don't have to have both on there, right?
And see now it's burning right at the point. Okay, see how it's only burning at the point.
Yeah. Yeah.
I don't like it. I'll tell you why. You're burning down below. You got no control.
No, we're not burning down below.
Yeah, you
Oh,
are.
down here. Oh, okay, this is coming through that's the wood.
I know it is.
Yeah, that's the wood.
Like I've done,
Yeah.
That's a really good point, yeah.
so Charlie, like if you really need control, I would use 2 probes.
Well,
Oh,
Two
just keep moving the rope, yeah, okay.
well, if you put the 2 probes, you'll be able to, you'll only burn between the 2 probes.
Yeah, yeah,
And just control with fluid, you know.
And
yeah, just keep moving many times.
this is the electrolyte in the solution that's going through the.
So actually the burn I like is the secondary. They look better than,
Yeah.
So it does have a.
you know, I've got hardly any watts or current. If you look at the pattern you get, it's way better.
No, show me how you can control these.
We're gonna try it. We're gonna get on
Next
that.
lesson.
That's cool.
I like
So this is a really good example of where Dave's system, maybe we can bring that over here, we can,
So what I wanted to do with this is control it and keep
You
it
need a new
between
pen?
lines.
no, that's.
Okay, got it, watch it.
So Bert, just keep it between the lines as you rotate. I find the hardest thing or the best thing is if you can get control. If you can figure out how to make it burn in the wood, like you know, the pencil was interesting. I never thought of that. I'm surprised. Like it works.
Oh, the
How did-
carbon track.
Yeah.
It'll follow the carbon track.
Well, they're burning names and
So
straight
the
lines.
electricity will follow the carbon track. I mean, but that's all experience.
It's
That's
conductor. It's
Absolutely.
conductor.
It's a conductor.
The carbon's good enough for you.
Yeah.
Big time.
So this has got a finish on it, Dave?
No,
No, it's polished?
So just keep it between the lines and see if you go all the way
So
around.
we want to burn that? Is that
yeah,
yours?
I bought all those things to be monkeyed with.
So one of the things when you're doing this is if you want to control this, is don't put as much solution on as you would. Like don't go all the way around because it'll just bugger up where sometimes it'll go wherever the solution is.
Pieces then.
So now, like you were saying, use the, is that as low as it'll go?
Let's see, go down further than this, Charlie.
You wanna get that up higher?
No, I was wanting to lower that down if I can.
No, there's a recess.
Is there a recess there? Dave?
So again, I think it's a good strategy, like it'll
Get
work
up higher using these.
when we get to the.
All right,
Let's
if you
first
want to succeed, get a bigger hammer.
Ouch!
Well, bro.
Who welded that?
It wasn't me.
My weld won't break.
Oh, it makes no difference. Wonder who, I can't remember.
You could
No, it
just
wasn't
block
me.
it. Just block it.
You, Joe?
No, it wasn't me, Dave.
I don't know how many welding friends I have.
Obviously,
Made my fancy.
we don't want to identify the
So you got an extension.
I made an extension for the same reason, for exactly what we're doing here. Sometimes I had pieces that were,
Oh, shit, that's
all
welded. Freaking epoxy.
Buddy.
Oh, yeah, it's fun.
It's just epoxy, is it?
yeah, not
Don't
even
you
welded.
have any CNA glue?
Yeah.
Don't bring your rocks, I'll weld that up for you. Matter of fact, you can now, I will weld that up for you.
No.
I get cocky, get 3/4 of the way around and then it takes off.
One of them up higher.
Like this will be interesting because the grains,
Yeah, that's gonna be different.
yeah,
What'll end up happening
you
is
just don't want to go sideways. Or
Yeah. it's gonna wanna go where the burn lines are. And so it might go there, so we may have to move it around. But the key on these ones is don't put so much solution all the way around, because then you don't know where it's gonna go. Again, when we start this, start it low, we're turned on, and we'll see what we have. And we're gonna,
Like I've done bowls with narrow strips like that, but boy, I'll tell you that, it depends on the wood.
okay, so we're at,
If you think you're
3.2
doing good,
watts.
then it comes in the inside of the bowl.
So, because it was at 3.2 watts and it was actually starting to burn, I'm only bringing this up just a little bit. And now we're at 8 watts. And you can kind of see it's burning in between.
How beautiful it is.
Yeah, some of the stuff in between is kind of jumping, like, again, how much salt solution soaks into the wood, and it will burn where the solution is. If you do it on plywood, it's amazing. You can burn and see nothing on the top, and then split the plywood, and it's all in the bottom.
But this is gonna be interesting, because when you, that's end grain you're on right now,
Yeah.
Yeah, exactly.
so as you turn it, it's gonna change. It won't be the same.
Okay, so now we circuit across there. If you decided you wanted to have a couple of branches on there, you can move that over. Just down a bit.
There you go.
And it goes across, but it burns right across. So that means that I'm putting a little bit too much power on probably.
Want another lift?
No, we're okay.
So a fun thing I've done is, I mean, Harry Potter one, with lightning up and
Yeah, I do a lot of those lightning ones there too. So now you can actually do a little bit of drawing. You can draw. I never liked closing the roof on something. So now, where's the next place you want? Do you want to just keep burning around it, Dave? or-
Any way you want. Maybe,
I'll tell you, there's a knot on the bottom there, try that. Let's see what happens.
Yeah, try to get it close.
Or around it.
What it'll end up, is that not all the way through?
Yeah.
And so if the solution goes all the way through,
Yeah.
then chances are you might end up with a little bit of.
So don't use that on the.
Not very much,
I
no.
won't put very much on there. And one of the things too is, a lot of times people will think, well, you got the 2 probes, you'll go between the probes. And that's true, but there are times when you can have it like this, and like this, and it goes that direction.
Yeah.
Okay, so sometimes
right around, right all the way around.
Yeah.
So it finds the easiest way home.
electricity finds its own path of least resistance. And then
Well, the
it's
thing you
like-
can't see is how the grain's going inside.
Yeah,
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 and we can't predict that.
You can't.
no. I'll let Mother Nature do that for me.
That's her job.
So again, I've turned this down to 0 or next 10%, and just to see what's gonna happen here in that 10%, it's 4 watts, 5 watts, and it's
It's heading towards the knot though.
heading towards the knot.
But basically, you're stopping just when once it's starting, you're stopping going up.
Yeah, well, I look at it to see what, how it's burning, and then I'll bring it up, so,
But that's interesting too, because you could make just little flowers at
yes, yeah.
the lower temperature.
But I've done that where
I
I've
keep my hand
got,
on it, but-
put a point in the center, and then put really, really wet around the outside.
Yeah.
And then just build little flowers on a different size, and then,
Like you could stop right there,
Yeah.
where that one is, and then you can move again, you can just
Just
make
move
little
it down.
flowers.
yeah,
And you could do that to keep inside your minds too.
absolutely.
You know, there's,
Yeah, you could just have little,
the limit is your imagination.
Absolutely. And if you put too much solution on here and the solution gets in these dark lines, it'll go in there and burn the lines deeper.
Yeah.
And sometimes that's kind of neat too, because you have a real nice smooth line, then all of a sudden it's a jagged line, and it's like you say, it's your imagination that makes it look like, how did you do that?
Yeah.
Well, it's also gonna run under the hard and the soft grain
Yeah.
too.
Mother Nature, where the solution soaks in and where it doesn't, will change the way that it actually burns.
but that's a real important thing, is how much fluid you put on all the time, and
Yeah.
how dry is it?
I sort of had the feeling, then I saw smoke, I didn't like that.
Well, no, it's smoking is good, because if it's not smoking, it's not burning the wood. So we're down to 1.5 watts, so basically it's probably dried up. Right, so it's probably dried the solution up, so it's
Just
not
check
making
and see if you're burning inside,
any connection anymore.
because the knot goes right through.
You were waiting for that, you set that trap.
Yeah, so it's too dry now, so even though it's too dry, let's just crank it up a little bit and see what happens. We can force it,
Bang.
right? So if you needed control freak and you think it's too dry, well, now with the Variac and with the power monitor, you can play that part you got control of. But you don't have control of how much soaks in and whatever.
Trouble is, if you go with the higher power, it's just instant.
Yeah,
Like-
and that's why I always start low and bring it up. And
I
bring
just
up
like it
and
when
bring
it's
it up.
barely burning and then, yeah.
So that knot is hardwood, and so it's the harder wood, so that's the way it is.
Yeah, you can make the rope holders out of just about anything.
Just about anything.
But those little ones we had, and the other ones were just round pieces I had kicking around. You
Yeah.
drill a hole in it, and these things here were, I seen it on Mike Peace.
Oh,
Just a piece of pipe.
Yeah.
And so I thought, okay, well, I'll try it. And then I only had this the first time, and then I started doing taller things, so I added a section. And they're not fancy, but they work.
I mean, this looks a lot better than the crack. Let's go to the inside. Why not? All the way around. That's typically, crack goes all the way through.
So you go out there. Yeah, that's good.
Yeah. So now we want to get across.
So that'll be interesting, because it should go right to that knot, eh?
Yeah.
See how that
Trying to
burns?
get that power done, is that your idea?
What are you trying to, with the crack and
Well, just to see what kind of patterns you have. It seems to be going so fast, you don't get a chance to get that.
Well, that might be the type of wood and the type of chemical too. Every piece of wood reacts different. If it's got straight grain with the tubes going straight, then it'll only burn where the tubes go. If you've got the ones that have really gnarly grain, where the grain's going everywhere, it sucks into the
That's
solution.
what Charlie was looking for, between his leaves.
Fingers on there.
Thank you.
He was pushing the buttons. And
Yeah,
you
thank you.
in there, so you've got to be really careful. You've got to be conscious of everybody else, guys.
Thank you.
You're welcome.
It's just. Yeah, so
Having
burn
two
it.
hand switches
That's working good.
makes it better, because when
that
you only
probably
have one hand switch, you're so tempted to reach over and just move it.
But that's probably what Charlie's looking for that bowl.
Okay, yeah, yeah. Well, these
you're gonna have the whole bottom done in there.
yeah.
But this is, it's difficult to do for a big group, really, to show. I don't think, because people sort of gotta be right into it.
Yeah, well, this is working. Is this working well for you guys here, having the two systems running?
Yeah.
I
Two
think
is enough.
Two is enough.
Yeah.
Three
Two
would
is
be,
definitely enough.
yeah,
Yeah.
three would be a bit too crazy.
I'd have my finger in too close again. Or somebody else.
Well, in theory, it could move right through the wood too.
No, because the transformer is isolated from everything else, the power is going in one probe and it's trying to go to the other probe.
But
Down again. See, you turn it down, it's still turning a little bit, so you can turn it up just a little bit, and you can see it. That's the beauty of turning it down when you
And you wanna
start,
get going?
because then you've got complete control.
I'm okay.
Still
Gotta practice.
You can turn the point up so it's a little bit pointy.
yeah, okay.
This is
So less
easier
than there,
just,
to make some of these, you need longer.
friction fit like that.
Well, no, I told me about some scrap wood, and I would always.
Yeah, you do it.
I'm not, that's okay, I would put those in the
Yeah.
build something around.
So what I find, like at
I
home,
tried to make sure
I
that
got
it was
my,
as simple as possible.
this meter on the wall, so I can see it.
Okay,
and then
yeah.
I'm sitting at a desk.
Yeah, if you're
Yeah.
at a spot that you're permanently set up to do this, like I have in a different room, in my RV bay, I've got a big table about this size and
Well,
that's
this is nice, it's
personally,
all compact.
like, yeah. Yeah, you pick a piece up and take it anywhere.
Hey,
And that took 40 watts to burn that little bit.
He's in the zone. I saw that Zen moment there. Ooh.